Hi, in this video, we're going to talk about a Python built-in data structure called set. So set in Python is just a collection of objects. And now it is actually very similar to math sets if you heard of things like set theories. And as such, because it's just another collection of objects, so another very familiar Python data structure that's also a collection of objects is list, which we have used a lot. So set in some ways is similar to list, but there are also some very significant differences, and I list them. The important ones here, the first one is that the elements in list is ordered, but the elements in set is not ordered. Second one is list allow for duplicates, whereas set does not. And keep these two differences in mind as we go through the details about set. The third one is about performance, and set is, it could be very fast when doing certain things. So, for now, we will just see how to use a set rather than how it's actually implemented, but we will learn how it's implemented later. So first, let's see how to make a set. So I've typed out the code here. The first way is if we just want to create an empty set, we can just say set and parentheses. The second way is if we already have some elements that we know to put into the set, we could use this syntax. Now, to say a set, we start with the curly braces and then each of the elements. And then finally, if we already have some sort of iterable such as list or a tuple that already contains elements that we want to be in a set, and we just want to convert or construct a set from that iterable, we can say set and pass that iterable as an argument to set. So if we run this, then what we have is, well, the first one is an empty set. And then the second and the third set, they're just set with 3 elements, 1, 2, and 3. So you might ask, why then when we create an empty set, why did we not just use this syntax, just an empty pair of curly braces? So be very careful when you do this though. Remember that curly braces is also used by another Python built-in data structure, the dictionary, right? So if you do that and you actually print out the type of the empty quote-unquote set that we just created, you might be surprised to see that it actually created an empty dictionary, not an empty set. So this does not create an empty set. Be careful. Okay, so the next thing I'm going to show you is how to add something to a set. And with that, I'm going to switch to the Python console just because it's quicker. So I can just use the .add method, and I can add an element to numbers, and that would be, now it has numbers 1, 2, 3, and 4. Now, remember, set does not allow duplicates. So if we try to add an element that's already in there, well, it won't complain, but it also won't add another copy of the element to it. So we already have 4 there. Doesn't matter how many more times we try to add 4, only 1 4 is going to be in the set. There is another way to add elements to the set. We can actually add multiple elements using this way, and that is using the update method and give it a iterable as an argument. So this is a tuple of 4, 5, and 6. So I did that, and if I say numbers, well, it's going to add 5 and 6 to it, right? It tries to add 4, but remember 4 is already there and it won't add it again. So obviously we can also remove elements from the set as well. So here I'm going to try to remove 6 using the .remove method, and after I'm done, 6 is gone. Now there is another way to to remove things, and that is using discard. I'm going to use now discard to remove 5 now, and once I'm done, 5 is gone. Now there is a difference between remove and discard, and that is discard when if I try to discard something that's not already in the list. Okay, well, I do that, nothing really happens, right? But if we use remove to try to remove something that's not in the list, well, remove will raise a key error because 10 doesn't exist in the set. So the difference between remove and discard is that remove will raise a key error if the elements is not already in the set, whereas discard does not. So much like a list or any other iterable, set can be iterated over using, for example, the for loop in this case. So if I do that, for I in numbers, I print out each of the i's. Well, I have 1, 2, 3, 4 in my set in the console, and that's what I have when I iterate over them. So in this regard, a set isn't different from a list. However, in terms of retrieving elements from a set, one big difference that it has from a list is that because there is no ordering in a set, we really cannot say, get the first element from a set or the second element from a set, right? Because there's no ordering. So set does not support retrieval by index like a list does. So if we try to say numbers and say 0 inside a square bracket, it's like, oh wait, set really doesn't support that, so we cannot do that. However, if you really want just a single element from a set, we could use an iterator and just get like the first element from the iterator. So now this happens to be the first, quote-unquote, first element in this set, but just remember, in general, there is no ordering in a set, so there's really no guarantee which of the numbers that you'll retrieve when you're using this particular approach. And that is what this slide is trying to explain. So what are some other useful operations we can do for a set? Well, we can retrieve the number of elements by using the built-in length function. Number of elements in this set happens to be 4. We can also check if something is in the set using the in keyword. So 1 is in this set, so that should give us true. And let's say 10 is not in this set, so that should give us a false. Another thing that we often do with set is we compare two sets to see if they are the same. So, and that's using just like our normal equality operator, the equal. So, numbers is 1, 2, 3, 4. So if we try to compare it to another set that has, say, just number 1, 2, and 3, well, that should give us false, right? Now, the interesting thing, though, is remember, there is no ordering in set. So when we try to compare the set 1, 2, 3, 4 to another set that is, say, 4, 1, 2, 3, well, guess what? They are equal because they have the same elements, and the order of the elements does not matter between these two sets, and that's why this comparison here returns true. And this is unlike list, for which the order of elements matter. So in a list of 1, 2, 3, and then we compare it to a list of 3, 2, 1, even though they contain the same element, but they are still not equal because those elements are not in the same order. So if we have a collection of things for which the order does not matter, then we should use a set. But if we have a collection of things for which the order matters, then we should use a list. So I've been talking for a while, and hopefully you have followed along and try out the code on your own. So here is an additional exercise for you to try, and that is, so we've been putting int in sets, which works. Now, what about sets of other built-in types, such as a set of lists here, set of tuples, set of sets, and set of strings? So try these out on your own, and some of them won't work. So, see which one doesn't, and see if you can actually see a pattern of which of the built-in type cannot be put in a set. All right, assuming you've tried it out, and here is what you would have found, that you cannot have a set of lists nor a set of sets. You can have set of tuples, and set of strings also work. And if you remember the main difference between these different types, other than they are different types, is that list and sets, they are mutable, right? Obviously, we can add things to the list and we can add things to the sets. Tuples and strings and int that we used previously, they are immutable types. So what you can put in the sets are things that are immutable. Okay. So now then you have a question, what if I have a list and I really want to put it in a set? What can we do? Well, what we can do is that we can construct a tuple from the list that we want to put in as elements of a set. So if we do that, and I'm going to take out the other things, then that will work. So let me print it out as well after I'm done. So once we convert the list to tuple, which is immutable, then it is okay to put in a set. So that's the built-in types in a set. What about user-defined types? Can we put those in a set? Well, the answer is yes, but for it to really work correctly, we have to do a few things. And that is basically defining the dunder hash and then the equal method. And also, we have to emulate the behavior that those types are immutable once we put it in the set. Now, we're not going to go into details of that here because, again, when we talk about hash tables, we will understand this a lot better. But I just want to mention them here. So one more thing I want to show you about set is the performance of one of its operations. So depending on what we do, certain operations between set and list, they're going to be very similar, such as if we want to iterate over every single element in a set and a list, it's going to run at about the same speed. However, some operations can be significantly faster for set. So, and an example of that is the containment check or the in keyword. So what I have here is a quick demo. So I am generating 5 million numbers, each of which is between values 0 and 10 million. And then I construct a list from these 5 million random numbers, and I also construct a set from the same 5 million numbers. Now, I'm going to look up this particular number, which I know does exist in these 5 million numbers. And I'm going to time the time that it takes to look up this number in both the list as well as the set. So let me run this. Hopefully it doesn't take very long. We should have a result soon. So in we find the numbers in both the list and the set, which is expected, right? Because they're the same 5 million numbers, just in different data structures. In the list, you can see that it takes about 0.2 seconds. In the set, it took single-digit microseconds. So this is many orders of magnitude faster than a list. So we'll learn why that's the case when we get to hash tables. So that's about all the operations of set that I want to go into detail for now. There are other very useful set operations, especially for your math types, such as you can take a union of two sets. As a matter of fact, the OR operator has been overloaded so that you can do a set 1 or set 2 to take the union. Same thing for intersection differences and some other set operations. So if you want to study more on sets, I have a few links here, including the one to the Python's standard documentation.